Introduction to JAKA Zoo SE series. The introduction to force control function will be divided in two main parts. 1. Introduction of force control SE series, and 2. General use of force control. The course time will be around 20 minutes, and the main objective is the preliminary understanding of a force control function. This product is designed to use industrial-grade force sensors and integrate force control algorithm with independent and textual property rights to improve the perception of collaborative models and provide customers with a better human-computer interaction experience. As shown on the figure below, install the force sensor on the end flange of the robot and transmit the force value to the controller in real time. When the end effector of the machine receives an external force, the position of the end can be adjusted to adapt the external force value. At the same time, customer can drag the position and posture of the robot more compliantly at the end of the robot. Zoo Force Control System includes APP robot, control cabinet, and force sensor equipment. The force sensor at the end flange of the robot are realized through the operation of the mechanical connection software at the end sensor module in the JAKA app. First, design the connection key between the force sensor and the end flange according to the actual needs. By connecting the key or setting the tool coordinate device, ensure that the X plus direction of the sensor is consistent with the X plus direction of the robot end flange. Then, the force sensor can be powered by the robot control or the user additional 24-volt DC power supply. Depending on the communication method for the sensor can be connected to the USB interface of the control cabinet for the serial communication, or through the network port for TCP/IP communication. If you choose sensor 1 or 3, you need to set the IP and port number in the app. For the specific setting method, enter the relevant sensor configuration directory. If sensor 2 is selected, IP and port number settings are not required. Force control automatic load identification function. When using a force control related function, you first need to set accurate load parameters. You can select manual input in the load setting, or you can use the automatic identification function. The process is as follows. Set the starting position, enter the manual interface, and move the robot to a suitable position. Click OK to exit. Set the end position when entering the manual interface. Only the 4th and 5th and 6th joints are allowed to move, and the range of movement is within plus or minus 90 degrees of the initial position. In the case of ensuring that the robot movement does not interfere, the larger the movement range, the more accurate the identification result will be. Click OK to exit the pilot operation, long press to set the starting position, return to the initial position, and long press the pilot operation to confirm that there is no interference in the identification trajectory. To start identification, long press to set the starting position to the return to initial position. Click Start Recognition. Wait for a few seconds. The app will display the end identification result. Confirm that the result is correct and re-identify. Let's take a look at the video of using the automatic load identification function. Use the force sensor in the interface of setting the hardware communication and sensor. Here, use sensor 2 to set the start position. At the end position, the rotation angle of the joints 4, 5, and 6 must be within 90 degrees. Then long press to the starting position to move the robot to the starting position. Then long press 4 points to run and check for interfaces. And then long press to set the starting position and move the robot to the initial position. Then you can click start to recognize, and the robot will automatically move from the start position to the end position. After the movement is complete, the current load will be automatically identified. Set the safety threshold in a sensor limit. During the movement of the robot, if the end of the sensor is set to be greater than the set threshold, the robot will immediately stop the movement to avoid danger or property damage. Let's have a look at the safety protection function of the force control. After disabling the sensor, configure the parameters in a sensor limit. Enable the sensor and start dragging on the teaching interface. When the detected force exceeds the limit, the display detects a collision and automatically exits the drag mode. Now we can try to run the program. The force control function is turned on in a program. When the external force is detected to be greater than the vertical limit, the collision will be displayed and the program will be stopped immediately. The force control traction test drive function enters manual operation. First, enter the configuration interface, where Fx, Fy, Fz correspond to the displacement in the 3 directions of x, y, z, and Mx, My, Mz correspond to the rotation in the 3 directions of x, y, z. By checking the checkbox in front of the direction, you can enable one or several directions. That is, if you can drag in the enabled direction after dragging is turned on. The smaller the robot damping force is set, the lower the drag force the user needs to drag. But the smaller the resistance is, the better. It is recommended that the damping force is greater than 10 Newton, the damping torque is greater than 0.2 Newton meter, and the setting value cannot be 0. For the rebound, the robot can return to the original position before dragging. The larger the setting value, the greater the force required to drag the robot. Check the tool coordinate system in the force control coordinate system. Then drag the robot in the set tool coordinate system and check the world coordinate system. Then drag the robot in the robot base coordinate system. When the controller enters the drag mode, for the first time after running, you need to check the initialization to compensate the sensor bias and load. And in the process of entering the dragging process, ensure that the end of the robot is not contacted by external forces. Otherwise, the compensation accuracy will be affected. After configuring the parameters, click OK and then click Exit to enter the drag and drop mode. Before entering the drag mode, the end of the robot should not be subjected to external forces, otherwise it will cause sensor compensation errors and cause danger. Due to the temperature drift of the sensor, if the robot position drift in the drag mode, please exit and enter the drag mode to perform sensor compensation again. Do not use the towing test drive function. Please exit in time. Now let's take a look at the video for the force control traction test drive function. First, we need to configure the force control parameters of the traction window. Here shows the X and Y direction. The damping force is a 10 Newton. Select Initialize and the current force control returns a value of 0. If you choose not to initialize, you can see the real-time value of force control in the viewing interface. Drag the robot in the X-Y direction. Then, we can observe the moving of the robot in the X and Y direction. Then we can add a rebound into the configuration. Open the drag again to manually drag the robot. After there is no external force, the robot will return to the initial position before the push of the robot. Turn off the drag and reduce the setting of resilience. Turn on the drag again and the force required to leave the original position will decrease. Open the configuration parameters, cancel the ribbon and select the parameters in all directions. Then enter the drag mode robot and you can do position and a posture drag. The constant force mode can ensure that the contact force between the end of the robot and the external environment is within the range of the set constant force value. Constant force mode includes opening constant force compliance control setting, force control coordinate system constant force compliance parameter setting, and closing constant force compliance control. The configuration parameters in the constant force compliance parameter setting interface are consistent with the traction teaching parameters. The user can set the constant force value according to the desired contact force value. The size of the resistance force needs to match the stiffness of the external environment. Generally speaking, the greater the environment stiffness, the greater the resistance value is required. Due to the temperature drift of the sensor, it is recommended that after the robot runs for a period of time, make sure that there is no external forces contact at the end of the robot, and select initialization to recompensate the sensor. Now let's look at the video about constant force mode. Configure the constant force parameter in a program. The Z direction is a 5 Newton, and turn on the constant force control. The running program has a tendency to move downward in the direction of the tool in advance. Check the force in the Z direction on the manual operation interface. It can be seen that the force in the Z direction is about 5 Newton. The fifth force controls speed mode function. In input mode, when the end of the robot is greater than the control force setting, the robot will decelerate until the sensor detection value is less than the control force setting value. Speed mode includes opening speed, compliance control speed compliance parameter setting, then compliance control force and closing compliance speed control. Configure the speed ladder on the speed compliance parameter setting interface and select the size of the control force on the compliance control force interface. Now let's have a look about the speed mode force. In the program, you can set the speed compliance and the compliance rate parameters. Then you can run the program. Now we are going to monitor the speed using the Modbus TCP. So we are watching the address table for Modbus, and we are setting the address to monitor the speed of the TCP. We can see that the speed of the TCP in a constant force is around 30. Now, when we apply a force on a force sensor, we can see that the speed is reduced. The sixth part, motion termination conditions. In the motion termination condition setting interface, check the direction to be monitored to set the upper limit or the lower limit. When the contact force value is less than the lower limit or greater than the upper limit, the motion neutral condition is triggered. The motion mid condition monitors the next motion instruction next to it. If the motion termination condition is triggered, the robot will immediately move from the current position to the end position of the next motion instruction. It is worth noting that all the parameters must be set to 0 in the constant force compliance parameter setting, and no direction must be checked. Now, let's take a look at the video using force control motion termination condition. Configure the motion termination condition parameters. Here, we choose the next first -5 Newton. The upper limit is 5 Newton. And then we can run the program. When the external force does not exceed the motion termination condition, the mechanical arm moves normally. When the external force received by the TCP is greater than the motion termination condition, the next motion instruction is terminated and the next motion instruction is executed. This is the end of this course. Thank you for watching.